Actually, on second thought, there is a reason to watch this. Just for the tips for programming thing, a point I often try to express to students is coding is just the tedious, busy work at the end. Uh, Most of the work involved in programming machines, feeding instructions into machines, is thinking about it, staring off into space, or jotting down notes, and then writing the code is just the tedious, busy work at the end after we've got our thoughts together. So, and it's quite easy because I'm just going to copy and paste this and do all of them that way. So, how many do we need? The two axes, the four buttons, and then a status. And I might do some grouping on the buttons, but I'll come back and do that later if I decide to. So for right now, we need seven conditions to check in our thing. So I'll copy that once to get the else if part. Now I'll copy that. So there's 2, 3, 4, 5, 6, 7. And now we can just go down and make these changes. So if it's not the x-axis, then is it the y-axis? If it's not the x or y-axis, is it the A button? And I'm going to copy that. If it's not the A button, is it the B button? If it's not the B button, is it the C button? If it's not the C button, is it the D button? And if it's not the D button, did the script just ask for this general status? Just a confirmation. So now we can change what each one does. So if the script on the PC asks for x-axis, we get x. Ask for y, get y. Ask for the A button, get A. B button, get B. C button, get C. D button, get D. And if it's the status, we'll just print the send back the word all is good. Something we can check on the other side just to make sure that it's connected and receiving commands. So you can see that the coding part had to have been less than 3 minutes because that's what the clock on the screen recorder currently says. And so it goes very, very quickly. But it was a lot longer than 3 minutes staring off into space and jotting down notes and all of that stuff, thinking about what to do before those last couple tedious busy work steps of typing that in. So might as well go ahead and do this while we're at it. Go ahead and update the documentation to list out what the valid commands are. So here in our Doxygen comment, the loop itself, we'll put a new line, and in the description, the loop simply listens for valid commands coming down the serial COM6 line and responds accordingly. Then I guess I'll put in a header tag to make that stand out. In a header, then I'll put valid commands and make a list of these. So we'll clean this up a little bit later. So our valid commands are x-axis, new line, y-axis, new line, A button, and might as well copy this. So copy, paste, paste, paste to get the B, C, and D. or status. X-axis to get the horizontal value of the joystick. And select all of those, copy that, paste that, and this word here will change to vertical. Paste that in to get the state value of the A button. Whoops. Shift and go to the end. Copy. Oh, I guess I didn't need the line break. Paste that, and then the B button. Paste that. For the C button. Paste that. For the D button. Paste that, and this is to get the connections to confirm the connections. Confirm the connection status of the controller. So you can see the coding that up and typing it did not take very much time. There was a lot more put into thinking about it, but just some quick copy and paste to get the if-else structure built. And I guess I could put it in here. If it's not one of those, then do nothing. Then if it's not one of our valid commands, then we're not going to do anything. Originally I was going to leave that off, but might as well spell it out explicitly. And then got the documentation ready to go for this too, which at some point later can probably come back in and add like an unordered list tag in HTML, but this is fine for now. So I think we're ready to give this a test and check all of our controllers, and at whenever we get around to rerunning the documentation generator, the instructions for what needs to go in the scripts on the PC side are there ready for us to use. So let's upload this and give it another test. Might as well make sure it compiles. Yep, and uploading, and I'm going to switch over to the video where we can see the controllers. Well, it appears I'm one hand short of being able to put the commands in here, which I just wrote in a text file so I can copy and paste one-handed with the mouse instead of trying to type these in one-handed while I push the controls with my other hand, which means I still don't have enough hands to hold the phone and take video while I do that. So I'll just have to narrate what I'm doing. So I'm start with the x-axis. Well, might as well start with the status. That's probably where we'd start with anyway. So copy that, come over here, paste that in, and it should be good to go. So when I send that, oh, we get back the confirmation. So now if we grab the x-axis, copy that, paste that in, and it should be about the 0 position. Send. -4, that's good. Well, not exactly good. That needs adjusted still, but we'll get that later. Paste that in again, move a little bit to the left, -45. Paste it in again, move a little more to the left, -90. Paste all the way to the left, and -100. And then we can check a couple values to the right, a little bit to the right, all the way to the right. So the x-axis looks good. And check our y-axis. So copy, paste. So right here in the middle is a 0. Paste. I'll just move up a little. Now down a little. Yep. So the y-axis looks good. What's next? A button. So copy that. Paste that in here. Not being pressed, we get a 0. Paste. Pressing the button is a 1. releasing the button should be back to a 0. So that looks good. And just do the same thing on the rest of these buttons. So copy this over, paste, that looks good, paste it, holding the button when that command comes down the line. Make sure the button is down, so now when I send the command, it will register that the button is down and send that back. That looks good. Release the button. So it looks like it's all working here because a lot of these we'd already checked parts of it, so we just need to make sure that these words work. C button pressed, and C button released. Still looks good. Now the D button, copy, paste, send the command, got a 0, paste it back in, press the button and send the command, get back a 1. And now for the final one, the D button is not being pressed when the command comes down, so we get back a 0. So it looks like everything checks out on the controller side of this. So all this should be good. I can clear this, close this out. I'm going to keep this around, so I'll copy and paste those because I know those are the right words. So I'll copy and paste instead of retyping because humans make typos. And now that I know those work, if I hit copy and paste instead of trying to type it, I know I'll be typing the right thing. So now we're ready to do the scripts that run on the PC side. Though before I jump into that and put those scripts together, we know the controller's up and working. And when we order the PCB, there's going to be a couple days delay while that comes from the factory. So before doing the PC side scripts, I'd like to go ahead and get the PCB designed and ordered from the factory. And that way when we put the scripts together, we can get the scripts together. And by the time we finish that PCB should be arriving in the mail. So let's look at that step next. Oh, and then, yeah, might as well run the document generator here real quick. Just since we added some more stuff to it. So where are we going? Basic control unit, documentation, documentation under Scratch. There's our doxy file, and we haven't changed anything about what files to look at. We just added a couple things to one of those files. So we can come over here and run that. And check how that new part came in. Oh, my browser's over here. Bring that back over on this window, the screen. Bring that window over to this screen. And it sure does seem to be taking a long time to load. Okay, not sure what the delay was, but it's up now. So if we come over to the documentation for that .ino file, we can see our description of the loop method, generic main loop. Yeah, it just checks what's coming down serial comm line 6 and responds to one of these commands. So it looks like everything's good to go. The next step, we should go ahead and get the PCB design together. And that way, while we're waiting for a couple days for that to come in the mail, we can work on the scripts on the PC. And then when the PCB, the printed circuit board, arrives in the mail, should be able to plug everything up and get be ready to test everything at that point.